Okay, let's do the 29th. That is derivative of x plus secant x multiplied by x minus tan x. Okay, again we have multiplication of two functions. Okay, product of two functions, that is, so we'll consider one function as u and the other as v. So u dot v whole dash, okay, will be u dash v plus u v dash. Okay, so let's find out u dash and v dash. So u is equal to x plus secant x, which implies u dash is equal to derivative of x plus secant x, so which can be written as derivative of x plus derivative of secant x, so which is derivative of x will be 1 plus derivative of secant x is secant x tan x. Okay, so this is u dash. Now v equal to x minus tan x, okay, which implies v dash is equal to derivative of x minus tan x. This can be written as d by dx of x minus d by dx of tan x. So the derivative of x is 1 minus the derivative of tan x is secant square x. Okay, so this is v dash. So let's apply these values in the formula. We'll have u dash is 1 plus secant x tan x multiplied by, next, v. What is v? V is x minus tan x plus u, that is x plus secant x. So v dash multiplied by v dash, that is 1 minus secant square x. Okay, that's it. Now the highest power, let's bring it to the right, to the left. That will be 1 minus secant square x multiplied by x plus secant x. Okay, this set. Now we'll write this as 1 plus secant x tan x and x minus tan x. Okay, this is how it's given in the textbooks. Okay, we could simplify it further if needed. See, 1 minus secant square can be written as 1 minus tan square x also. See, we know 1 plus tan square theta is equal to secant square theta. We know the formula. Okay, trigonometric identity. So here if you take tan to the right hand side and bring secant to the left hand side, it will be 1 minus secant square theta is equal to minus tan square theta. Okay, so instead of 1 minus secant square x, we can write tan square x. So minus tan square x and x plus secant x plus 1 plus secant x tan x, x minus tan x. Okay, that's it. We can write this here and this here also. Okay, no problem. This is just multiplication both. So that's it. This is the final answer. Okay, okay, let's do the 30th. So this is again in the form u by v. Okay, the quotient rule, division of two functions. So this can be considered as u and v. So u by v whole dash will be u dash v minus u v dash upon v square. Okay, so now let's find out u dash. U is equal to x implies u dash will be derivative of x, which is equal to 1. Okay, this is u dash. Now sine derivative of v is equal to sine n raised to x, sorry, sine x whole raised to, see, you can write, see, sine square x is equal to, we can write this as sine x whole square. Okay, sine square x is equal to sine x whole square. See, we can write in both ways, okay, with the same. Okay, so we'll write sine power n x as sine x raised to n. Okay, so if you write this form, it will be a little bit easy to calculate. Okay, so we'll use this form. So v is equal to sine x whole power n, okay, or sine x raised to n, which implies now v dash is equal to, now this is in the form x raised to n. Okay, so d by dx of sine x whole raised to n. Okay, this is in the form x raised to n. Okay, so we have to use chain rule, okay, here, and differentiate sine x again. Okay, so this will be, we'll assume this as x, so x raised to n, so it will be n into sine x whole n minus 1. Okay, and d by dx of sine x again, so n sine x whole n minus 1, derivative of sine x is cos x. Okay, so this is the v dash. Okay, well, let's put these values in the formula. U dash v dash, so u dash is 1 multiplied by v. Okay, v is sine x whole power n. Okay, let's use it in this way only. Minus u is x, and derivative of v dash, so this one v dash is derivative of v, that is v dash is n sine x raised to n minus 1 cos x, okay, upon v square, that is sine x raised to n whole square. Okay, now this can be written as sine x whole power n minus, this can be written as nx sine x raised to n minus 1 cos x upon, this can be written as 2n. Okay, sine x raised to 2n. So you know that a raised to m whole n equal to a raised to mn. Okay, you have this formula. Okay, so it become n raised to sine x raised to n whole square will become 2n. Okay, according to this. Now you see here, you can take sine x n minus 1 common out. Okay, here you have sine n raised to n, so we'll take this common, so it'll be sine x n minus 1, so this is common, so here you will have sine x, okay, minus nx and cos x, okay, upon sine x 2n raised to 2n. You see, if you multiply this both, and now this its power is 1, so a raised to m into multiplied by a raised to n is equal to a raised to m plus n. Okay, you know this, so this is sine x raised to n minus 1 multiplied by sine x. Okay, that will be 1. So when the bases are similar, the powers can be added. Okay, and multiplication, so this will become sine x n minus 1 plus 1. Okay, so this positive 1 and this negative will cancel, you get sine x raised to n. Same thing just here, so when you multiply this both, you get this. Okay, that's it. Okay, now you see what we do. Okay, now you see this both, These both are in the form a raised to m upon a raised to n. M, okay, both bases are same, but it's division, so we can write this as a raised to m minus n. Okay, here when it's multiplication you write it as a plus a raised to m plus n, and when it is division form, both the bases are same, then the powers will be subtracted, m minus n. Okay, so this both can be written as sin x whole raised to n minus 1 upon sin x raised to 2n. Okay, so this can be written as sin x raised to n minus 1 minus 2n. Okay, so negative 2n and positive n, it will be subtracted and you will have negative n. Okay, so it will be sin x raised to, so you will have minus 1 minus n. After 2n, negative, from negative 2n, a positive n will be subtracted, so you will have negative n remaining. So this can be written as, so now a raised to m upon a raised to n is equal to a raised to m minus n. This will go to the numerator part, okay, upper side. So this will be sin x whole raised to minus 1 minus n. Okay, this one doesn't go to the numerator side, multiplied by sin x minus nx cos x. That's it. Okay, this has been subtracted and gone to the numerator part side. Now see this, now we see you can write 1 x squared, you can write x squared as 1 upon negative x. Okay, or x raised to negative 2 can be written as 1 upon x squared. Okay, so this can be written as 1 upon sin x raised to positive. This becomes positive, so we can write this as sin x, this one sin x minus nx cos x upon, when this comes down to the denominator it becomes sin x, this becomes, the signs become positive, so 1 plus n. Okay, and this can again be written as n plus 1, sin x minus nx cos x upon sin n plus 1, sin x raised to n plus 1. If you need, you can again bring it back inside. Okay, like sin x minus nx cos x upon, so this is the answer, final answer. You can write it as it is in the textbook, that is sin, you can write this as whole as sin n plus 1 x. Okay, both are same. That's it. This is the answer.